So in part 1 we have obtained the prop reaction for the given problem. Now we'll continue the solution of this. So after calculation of this prop reaction, we can easily go for the shear force calculation. For the calculation of shear force, as we know the unknown reaction at the prop. So now here let us consider the downward forces as positive and clockwise movements as a positive. So shear force at intersection between B to C will be 15, as at free end there is application of load of 15 kilonewton. Now at B there will be shear force of 15 kilonewton downward, as we are considering downward as positive. Therefore shear force at B will be 15. Now B to C, again there is no loading, hence there will be straight line of magnitude 15 kilonewton, or we can say shear force at any section between B to C equals to 15 kilonewton. Now what about shear force between C to A? So shear force at C can be obtained as this downward shear force of 15 kilonewton minus this upward prop reaction. 15 minus 26.25 equals to minus 11.25. So shear force or net shear force at C after the application of prop will be minus 11.25 kilonewton. Okay. Now again A to C there is no loading. Now there will be a straight line in the shear force diagram, and shear force will be same between C to A as minus 11.25. What about at shear force at A? Now for this shear force at A is nothing but equals to this 11.25 plus this upward reaction at A, that will become 0. Now let's go towards the bending moment calculation. We'll move from free end. So as we know, at free end moment will be 0. Now moment at C, clockwise we are taking positive. 15 is clockwise into 2. 15 into 2 will be 30 kilonewton meter clockwise moment. Now moment at A, sum of these all moments, that is 15 into 2 total span 6 minus this upward anti-clockwise will be negative 26.25 into 4. So we will get bending moment at A equals to minus 15.0 kilonewton meter. Got it? Note it down. Now here you can see at free end moment is 0, at fixed end moment is negative, that is hogging, and at the point of application of prop it's positive moment of 30 kilonewton meter. Now in between C to A, from prop to the fixed end, the moment is changing from positive to negative, or we can say the sign of moment is changing from positive to negative, hence there will be a point of 0 moment in between A to C. Now let's draw shear force diagram based on our calculation. This is our beam. We have calculated shear force at B as 15, B to C is 15, and C to A is minus 11.25. Shear force diagram will be like this. Now what about bending moment diagram? Yes, at B it's 0, at C it's maximum 30 kilonewton, and at A it's minus 15 kilonewton meter. Diagram will be like this. Now here there is a movement changing from positive to negative, or net movement at this section is 0. Now this point is termed as point of contraflexure. Now this distance is 1.33 meter. How to calculate this distance? Now let's see. Let the point of contraflexure occurs at a distance of x meter from the fixed end. This is a beam. Let us consider a distance of x. Point of contraflexure is there. Now to find this distance x, take a moment of forces about point of contraflexure. From this point we will take moments and we will equate it to 0. As we know, at this point moments are 0. So 15 into this distance, total 6 minus x. How much it will become now? 15 into 6 minus x. Second force upward, anti-clockwise, negative, P we have obtained as a reaction of prop as 26.25 into this distance, that is 4, total is 4 meter, and this x will be reduced, 4 minus x into 26.25. we'll equate it with 0, as at point of counterflexure moments are 0. So by solving we will get the simplified equation as 90 minus 15x minus 105 plus 26.25x equals to 0. Now solve it and tell me the value of x. You can solve. Okay, then x will become, by simplifying it as a 11.25 x minus 15 equals to 0. This is a simplified form of this equation. Okay, so we can say x equals to 15 divided by 11.25 equals to 1.33 meter. Now understood? In bending moment diagram you have seen the distance of point of contact is 1.33 meter from fixed end. Understood how to find the distance now? Okay. Now position of point of contact flexure is 1.33 meter from fixed end A. Likewise you can mark the point of contraflexure. Hope you understood this. So let's summarize what we have learned in today's session as well as in previous sessions. So we have learned prop cantilever beam as a indeterminate beam. Its indeterminacy is 1. First we have to calculate prop reaction by using consistent deformation equation, that is by equating deflections. The equation of deflection at free end when load is in between fixed and free end, we have know that equation as equals to W into L1 cube divided 3 EI plus W into L1 square by 2 EI into L minus L1, or someone can say L1 as a and this L minus L1 as a B. Also we have seen how to draw shear force diagram, which can be drawn by using shear force values, and we have calculated shear force values at node points, which is determined by the reactions and loading conditions, and also bending moments are determined at silent points, that is at point of contraflexure, at supports, at point loads, etc., and we have drawn the bending moment diagram accordingly. So let's have a quiz. Hope you can answer. The prop reaction at the free end of a cantilever of span L and subjected to UDL of W per meter throughout its length. What he is asking? What is prop reaction at free end for a prop cantilever of span L subjected to UDL over the entire span? Okay, and options are 8 by 3 WL, 8 by 3 times 3 by 8 times WL, 5 by 8 times WL, and 8 by 5 times WL. So by using basic principle or equating deflection, we can find, as we have obtained for the point load or point load acting at a midpoint or concentrated point load. For those we have find the equation or value for the prop reaction. So likewise we can find the reaction for the beam or prop cantilever beam subjected to UDL over the entire span. And correct answer for this is 3 by 8 times WL. So it's your task, solve it and compare your answer. Second question, the value of deflection at the end of cantilever of span L subjected to point load W at free end is. What is asking? Value of deflection at the end of cantilever span. Okay, so you can answer it now. Options are WL cube by 2EI, WL square by 2EI, WL cube by 3EI, and final option is WL square by 3EI. We have seen this. Can anybody answer? Okay, the correct answer is WL cube divided by 3EI. Hope you can remember this. Now based on this, in examination it may ask some of the questions. So these are the frequently asked questions in examination. You may note it down. Okay, so we will stop here. Thank you.